So we'll go through some of them. So the first graph asks for the graph y equals 2. Y equals 2. So what does this one look like? We need to think. Is it going to be horizontal, vertical? What kind of line is it going to be? It's horizontal, right? So, okay, how do we know that it's horizontal? So horizontal is like that. How do we know it's horizontal? What is this literally saying? Yeah, good. That's one way of thinking about it. So if you think about it in terms of y equals mx plus c, what would this be written like y equals mx plus c? Because obviously this isn't looking like this at the moment, but how could we make it look like that? How could we rewrite this so it looked like that?
Y equals mx plus 2.
Okay. What would the gradient be? It would be 0, right? Because 0 times x would be 0. That's how we could get the y equals 2. Okay. So if the gradient is equal to 0, remind me, what does the gradient mean again? Like, how do you define gradient? It's the slope, exactly. Another way which you can think about it is every time you move across by 1, it's how many you move up or down by. So if you move across by 1 and the gradient is 0, how many should you move up or down by? 0, okay? So your y-intercept is at 2. Y-intercept is 2. You go across by 1, you don't go up by any. Go across by 1, don't go up by any. Cross by 1, don't go up by any. Would you be happy that would just give you the line which looks like that? Does that make sense? Yeah? Did anybody else think of it in a different way? So thinking about it in terms of this is absolutely fine. Did anybody else think about it in a different way? So you remember a straight line is just a rule that defines a set of points. So this y equals 2 should define every single point along this line. They have something in common, and it's y equals 2. Now, what does that mean? If the rule is y equals 2, what's the rule actually saying? Can you put it into sort of everyday words for me? Okay, well, if I write something like this down, what's this rule? What does this rule tell me? Good. Or how can it connect together all of the x and y coordinates? Because, of course, a line is just a set of points, yeah, which all share some common relationship. What's the relationship here? How can I get the y coordinate from the x coordinate using this rule?
By making x equals 0.
Okay, so if x equals 0, what would y be equal to? If x equals 1, what would y be equal to?
5.
If x equals 5, what would y be equal to?
17.
Okay, so what's happening here? I give you an x coordinate, how do you get the y coordinate? Yeah, so you're literally saying this line here connects together all of the points which have a y coordinate which is 3 times the x coordinate plus 2. Yeah? Now if I use that theory up here, am I being told anything about the x-coordinate? Am I using an x-coordinate at all? No. So it basically says, regardless of your x-coordinate, your y-coordinate is always 2. And if you look along this line, every single point along this line has a y-coordinate of 2. Okay? So think about it like this as well. This is just a rule that connects together a set of points. Okay? And it's literally just saying, whatever your x-coordinate is, your y-coordinate is always 2. Okay, and then just think about where those points are. So it has to be here. Has to be here. Does that make sense? Good. All right. What do we get for the next one? So the next one is x equals 6. Can we use that same kind of theory, that same kind of understanding for x equals 6? So actually in this case, could we use y equals mx plus c? What do we reckon? Could you use y equals mx plus c here? I don't think so either, because I don't think, no matter how you rearrange this, you can get a y equals something, okay? Like up here you could, just by thinking of it as 0 times x. But if I try and rearrange this, I could get, well, okay, 0 equals x, negative x plus 6, okay? But there's still no y here. There's still no y, and there's no way that we can get a y from here. So actually, y equals mx plus c is not going to help us in this case. So could you use the theory which I just taught you with this, okay, this idea that's basically a set of points that all follow some rule, to think about the set of points, think about the rule which is defining this set of points? What do you reckon? What is this literally saying?
Goes up by 1, it moves by 0.
Well, that would be this one, so the gradient is 0 here. Don't think that quite applies here, though, because there's no y equals, so we can't extract the gradient from this. What do you reckon? What does this rule actually tell me? So this rule just says, regardless of your x-coordinate, your y-coordinate is always 2. What's this one telling me? Absolutely right. So x will be equal to 6, the x-coordinate will always be 6, regardless of what your y-coordinate is. Does that make sense? Yeah, so this one, regardless of your x-coordinate, your y-coordinate is always 2. This one, regardless of your y-coordinate, your x-coordinate is always 6. So let's find a point with an x-coordinate of 6. That one would work, wouldn't it? This one here. Yeah, that's literally 6, 0. Okay, so my y-coordinate is 0 in this case. Could you find me another point? What about that one? That would be like 6, 1. Or this one, which would be like 6, 2. Or this one, 6, 3. Or 6, 4. Or 6, 5. Or even go negative, 6, negative 1, 6, negative 2, 6, negative 3. Okay, can you see that this line here is now going to be a vertical line? Does that make sense? Yeah? So think about this. This is literally just a line. Think about the rule which is defining this set of points. Okay. So you notice when it's just got y equals 2, it's just a horizontal line. But now you've got x equals 6, it's a vertical line. Does that make sense to everyone? Yeah? Okay, good. Have we had a go at the next one, which is y equals 3x plus 2? So this one should be on a little bit more familiar ground because we've looked at straight line graphs before. So can anybody tell me how I would go about drawing this line?
So we get the y-intercept.
Yep, which is?
2.
Good.
And then we have gradient, so 3 over 1, which means we move by 1 and up by 3.
Absolutely perfect. Okay, so we start there at 2, we move across by 1 and up by 3. Yeah? So would you be happy we would get something that looks like this? Yeah? So you move across by 1 and up by 3, 3 times the distance. Is that okay? So we literally pick any point, move across by 1, you move up by 3. To be honest with you, this is just a sketch, right? This is just a sketch. So we don't have to sit there and plot it exactly. So remember, the word sketch just means, just give me the idea of what's happening here. So mark the important points on, for example, 2. That's important because it's the y-intercept. Okay? And as long as your gradient looks like it's worth 3, so you go across by 1 and up by 3, that is totally fine. Okay? You don't have to do anything more advanced than that. All right?